Today's day is the 5th of March 2026. The time now is 7:43 a.m. Is this going to start Audacity? Yes. So 7:43 a.m. is the time. The time now is 7:43 a.m. So this video is on parapsychology for framework for sensory infrastructure. So you get two types of people. You get people with hypo, like to seek out information in the sensory outlet to determine what things are via rhetorical reasoning and rationale. And you get hyper. Now, hyper people like to seek out, like to really have information there, but they have to seek out less. So it's who can see. So hyper people seek out more information in the system. But hyper people seek out more. So this OBINexus sensory infrastructure based on human rights framework of my human rights framework. So continue with this method. So today I'm trying to present some kind of things formally, but I won't be drawing my board. I'll just be maybe just drawing on purpose. I have the book here. I might just use it. So the goal is to have a stable foundation for sensory infrastructure. So you're gonna have a linear scale, a bipartite, bidirectional order of hot and cold. Hot is defined as a matrix of above 0.5, above 0.5, above 0.5. That'll be 0.6, 0.7, 0.5 is fine, 0.3, but less than 1, less than equal to 1. So it's basically above 0.5 hot. So hot is hot is in the middle here, and cold is between minus 1, can be minus 1, minus 0.6, minus 0.5, minus 0.3. But it's usually on the opposite side of the scalar. So there are dimensions of something called parapsychology. So I want to say something to fool. This is a parapsychology framework because I want you to be able to fool the system. It's a soundness proof I'm trying to work on. But mathematically it sounds. So this is hot here. It's called anything that's hot. Can you see? It's actually a matrix of cannot be in a threshold of cannot be in opposite threshold. So this basically works because it's the model is coherent with respect to its own self. You cannot classify something as hot and then determine its code later based on the signature. This is a mechanical operative minus. But unless it becomes cold via a thermodynamic scale. So it cannot be cold if it does not have a thermodynamic scale. So the goal is basically to minus 32 Fahrenheit, which is equals 0 newtons of force. You have to add. But this is a thermodynamic scale, so I can't know my model of it. But basically, you get a thermometer. A thermometer is 100 degrees Celsius is the boiling point for water. But you get something that's hot. Things that are hot are 32. I'm lukewarm, so I'm 32 degrees Celsius. So it starts at 40 degrees. Things that start only thought of 40 degrees Celsius, I believe, approximately 40 degrees Celsius. Things are now hot. So I'm saying there's a force. You can compress water, or you can boil water. You can excite the water particles to 40 degrees Celsius. 42 degrees Celsius water boiling point, and you can basically 42 boiling point. So start getting excited. So water molecules start getting excited. You can start to bounce around and hit yourself fizzle, and because they are being separated into being excited by heat. So thermo means heat. Dynamics means the physics of the heat, the physics the ongoing reaction in the chemical solitude. So the word solitude refers to the kind of infrastructure here. So these are parapsychology terms. I want you everyone to saying that things are hot. The computer is hot when it's cold, because parapsychology is basically about it's going to tell me the system is hot and it's cold, because everyone's going to treat my computer system. So it's called sensory infrastructure because it works in your senses. So we have I have in the human framework I have 80 human rights because of my sensory infrastructure. So I have So I can touch stuff. I can touch this stuff. I can tell you this feels like a wood. Wood. This wood was just like wood, but it's bumpy, so it's a texture. So you have sensory as a texture, and the texture is basically power. So this is like wood. This one sense I have. This one sense I can act on by touching it, and one sense I can't act on. It feels like wood. It is wood. It feels like wood. It is wood. But it has a texture. So it has a bumpy texture to it. So I can say it's bumpy wood. Bumpy wood. So this now describes this my diary as bumpy wood, made of bumpy wood. It could be things like birchwood, bumpy wood. So any bumpy wood would be this is a verb now. So this wood is bumpy because you can classify it as bumpy. So I can tell you this wood. Like, you can lie to a computer. You can lie to a computer. So the rhetorical analysis of this word would be it is the surface of the book is textured. The surface of this without saying wood, without saying the word wood. Without saying because wood doesn't really imply any texture there. So if it comes to texture, you gotta understand the texture. So the surface of the item of the diary is bumpy, jagged, emitting and dark and dark black and black and dark black and red dark black with red symbols as writing as writing. The text. So my this is for instance my the so this stuff basically this one sounds counterintuitive, but I'm just know what it feels like. So my rhetoric basically why I did it. So I checked the paper. The rhetoric shows that it's the rhetoric for the fact of doing that is to feel what it feels like. So to understand the feeling of a word or of the surface of a book. Now that's this sort of this diary I have here, Namdi, is sensory literature. So it's basically my own diary I have, but it's basically for work ethics. So it allows me to work concisely, but it's a bumpy red. So it's a bumpy red surface. So I'm feeling right now. I'm feeling the surface of it, but it's bumpy. So the diary of the sense. So I'm trying to describe it via rhetorical reasoning rationale. So I wrote here. The sense of the diary is bumpy, jagged, and black and with red symbols as writing. That's basically me developing my sensory infrastructure practice. I'm going to develop my sense of information around this what this material is. But it seems like a hard wood. Like a wood, if I knock on it, I put pressure on it, and I'm describing the pressure. So I can understand the pressure. The pressure is that of a hard, of a textile material, of a knock on the wood. It sounds like a door knock, echoing door, the beckons. It echoes and it beckons. So it's very important to understand. This is not a joke. This is science. This is sensory infrastructure I'm building. So you get two types of senses. You get open motor, open people, and open motor. So open control, like motor. They like to. They are hypo or hyper, but they like to do things fast. So it's really for people who do fast. People who need more, seek out more information. So you have hyper, but the people that are open motor. people that are like to just go for it, like just get on with it. Doesn't matter if you give them a new tablet, a new phone, a new iPhone, just like to use the interface to do what they want to do. It's very important to distinguish that in your framing. So you go open sense. People that use the sensory so to determine with their own senses, like slowly get into which it's not a slow process. It's just they have to understand they need to get on with their own sense, their own sensory. You have open sense. Remember that. So this will be github.com/OBINexus, O for Oscar, P for Papa, E for Echo, N for November, M for Mike, O for Oscar, T for Tango, O for Orange, R for Roma. Now, open motor is related to open motor neurons, like the ability of motor neurons. Motor is called open motor. They're like a physical car, but physical motor neurons for dyslexic people. But it's aimed for the worst case majority, so it's aimed at dyslexic people. So the open motor framework is disguised as the one worst way. Because the other also the worst case. And that worst case is has no baseline. The worst case has no baseline. Based on the society of the world, that's why I have no baseline with them. So because you can, someone can use their hand tomorrow, and we don't control tomorrow. You have to sustain them. So you can use the computer with one hand. That's why your operating system, Muco OS, uses one hand. So you use your one hand to log into your operating system. You type your command, pum pum pum. You log in. You use one hand to do everything on Muco OS. So basically, the goal is to have github.com /OBINexus MK2 M for Mike, U for umbrella, K for kilo, O for Oscar, dash O for Oscar, S for which is Muco OS, the world's first operating system, human rights operating system. So neurodivergent human rights operating system. So you get ADHD Type 1, which is space first, but I'm inverse type 2, so I'm ADHD inverse, so I have the time to act on something and double the space. So I have more time. So I have double the space for going to compute, and I have double house. But I'm time first. Time first. I prioritize time, so I'm double the time actually. So you get half time, double the space, half space, double the time, half time, double the space, double space, half time, half space, double the time. But I am basically half the time. I'm double the time and half the space. So I'm the polar inverse of time first. So because I require double the time, I really have double the time for every task I do. So the hypo people and open sensory filter is for like parapsychology. I could do parapsychology based on the problem of next problem. So the problem I'm saying the sensory filter is for sense people that have sense, who have sensory sense are heightened more than others to do. So let's compare this mathematically. So you have, for example, you have a tennis ball. And the tennis ball is round. So you want to pick up a tennis ball, and the tennis ball is round and soft. It's soft and round, but the smooth ball too is also smooth and round. So which have isomorphic properties. They have topological isomorphism. Because the red the tennis ball, I can't call it tennis ball, is smooth, and so is the tennis ball in this hand. The ball is tennis ball, and it's another tennis ball here, guys. But it's smooth. But I remember sense of it's smooth, and the pool ball is also smooth. So you get a tennis ball and a pool ball. So the tennis ball is this one, the pool ball is here. Follow on. So if I squeeze them, if I squeeze the tennis ball, I will not be able to. I will get cushion in the tennis ball, and in simple, I will get my hand either blistered, not blistered. I will get my hand. What do you call it? I'll give my hand. I'll give my hand a hard surface. I'll get it's kind of uncomfortable. If you call it. So it's not about the comfort per se. I'm doing an analogy. What I'm going to do is provide is a framework for open sense. So so the reticle, reason, and rationale is they're both smooth surfaces, but one is harder than the other. And this is from the I don't want to computer to be fooled by fooled by senses and fooled by senses. My computer works on computer lattice. So my it's not how you interact. That's what lattice is. So the lattice basically ensures that these two processes are not isomorphic because they have topology. They have isomorphic properties. So they are both soft. No, they are both smooth. One is soft one is hard, they're just both smooth, and that's the smooth at the same time. So that was the first problem of the system. So in a hot and cold system setting, what we define as smooth is the Muco OS precision accuracy of a measurement. So that's what quantum challenge is for. The more accuracy the more you can distinguish something from something else, and it's a classification problem. It's a baseline for classification. So it doesn't matter if the small syllable is really smooth or not. It's a bad tennis ball. You can still determine it's a tennis ball, and if the golf ball is really jagged, you can still determine it's a tennis ball because we are human beings. We don't need to think about that. Also the non-holding clause. So computers doesn't need to hold memory. You don't have to hold a photon, to use it. You don't have to hold the properties of photon. So you have, for example, you have a trait model. So you basically people will just people that are open motor have traits. So the traits and the motor and evolution have traits. All have traits. So the traits are basically the action. So the action is the phenotype of the feature. So you have a hand, a palm, you have a hand here. But some people don't have two hands. So they can operate a computer as well. So that's what Muco has one hand. So a one-handed keypad is the best thing. But the mouse, one-handed keypad and one-handed trackpad, So the computer will not be, so basically you're going to have a design philosophy of the system based on the sensory infrastructure of the person. For example, you have the keypad on the right and the trackpad on the left. And that's the simplest one. Simple by design. Trackpad on the left, keyboard on the right, so like this, But you just have to use this computer I'm building. So right now, so that's the human computer I'm building. So it will be a hardware and software, but the hardware is on the right, and it's this component, this joint, it's component is this joint. It's a polyglottic. It's polydactyl, I'm saying, it works on a kind of lib polycle, github.com, OBINexus, OBINexus lib polycle, or lib polycle v1 on OBINexus MK2 repository. So those are problems there in that state of mind. But the problem I'm trying to resolve is the kind of duality between the physical sense, the hardball, and the sweet and sour. So sweet refers to things that are sweet, like sugar and tea. Sugar gives identity sweetness, a sense of sweetness, a sense of sweetness. But sense of sweetness isn't salty. You can always determine that from salty, like salty tea. When it gets dissipated in, sweet to, and mixing the two gives you a texture of rebuking. You don't like that, and so the sweetness and the saltiness are not isomorphic because they don't share the same properties. They don't share the same traits either. The salt is used for food to make you they share the same traits. They share the same traits, but don't share the same properties. So the salt is for cooking food to bring a flavor of carbohydrates or things you're cooking like carrots, peas. Like bolognese sauce, they like if you look at space bolognese which are made. So spaghetti bolognese which are made before, so you gotta have salt in it. I put salt in it. You're gonna put oil in it, and when you put tomato or salt in a food such as small bolognese, it's gonna bring out the flavor of the onions and the tomatoes and the carrots and the things already in the bolognese, in the sauce in the steam pan. So you're gonna understand that the goal of this is to have the trait model separated again from the actual model of the phenotype. So the behavior of the sensory phenotype. You get a sensory ontology type. You get a sensory phenotype. So phenotype, sensory phenotype, the features of the system in place. So you're gonna have chickens are gliders, not flyers, because the wingspan is not for them to fly, but it's there for them to glide through the wind in a dense wind. You can glide down or glide up, glide up. If they know how to do that, But they're not flying, they're gliding. So they're gliders, not flyers. So that's a feature, that's a trait. It's called a trait. T for tango, R for Romeo, A for Alpha, T for tango, I for India. So the trait is phenomenological. It operates on the surface stream of reference. But it's not only observational. It's not only phenomenological. We don't know whether food can breathe. But this food have like so. If it's a kind of a trait, because flowers, I believe flowers are alive for some reason. I don't know. I'm saying that, but there's a flower to me in my head. The flowers have sensories and the senses are flower based, they're flower bound, and the flowers are beautiful. Flowers are naturally beautiful. So the traits of flowers, they are there for feeling, and those traits we can feel from them, we can get from them, we can sense, we can perceive from them, and those are called phenotypal traits. They're phenomenological traits of observation and reference, based on how close the system is. So the problem is to formalize the system as a trait system via a radical reasoning rationale that can be described into words. Because if you can describe in words, the system has failed you, and you don't want a system that can give you food more than failing you. So, for example, the hot and cold dilemma has a sparse matrix, but this one is not good enough. So, the sparse model will be the one that contains sweet and sour. So, if I add hot water and sugar and salt in hot water, I should be able to taste salt salt in hot water. Now, salt in hot water will be a trait, a feel trait of the system. It becomes part of the water. This is when it's stirred. It becomes salty water. And this water is not dirty water. It's just the phenotype is a sparse. So when you get cold water, you have some tangy taste. It'll be tangy in water, hot water. And the word tangy is like a tangerine. So it'll be tangy like it'll be like a distilled like needle-like speed. But the more pressure you apply on the surface, the more salt there is, the more tangy it will be. Tangy will be tantalizing, but it's not as sweet as it's not as sweet. So, but the tanginess is removed when it's hot water. So you cannot get the hot water in a tangy. It'll be sweet. It'll be sweet. But you can still put it if it's the tangy is still in hot water, but it will be dissipated as a friction of you get a sight of the hot water, and you get a sight. The hot water will be salty. So if they're both salty, hot and cold is salty, and it's a salty, hot and cold water, you get a unique distinction from the sweetness. It's something that's distant, and you don't have to pick up more. You want to ingest more because your tongue are attracted now. Your tongue is starting to taste the texture of the system. You can verbalize this thing, verbalize with a radical reason. So you're going to write it down manually, so people cannot feel your situation and claim something from your practical. So you're going to have the sensory feature preserve your human rights. Your sensory. If you want to smell, so you can take a break. So, if you try to smell, you can take a break. It's putting order from your body. It's going to try to clean your gum, come shower. It's basically a computer that can know your emotion and know the surface around you. Because if your environment is not clean, you can't work with your computer directly, and you can't work with the operating system, Muco OS. So it's not a sparkle. So basically, how to know you can use it. Sparkle just means many ways, and so you can have a hot sweet, cold sweet. Hot salty and cold salty water solitude. So this is the medium of so the solitude is basically a sensory infrastructure based on parapsychology. Why parapsychology? Parapsychology is basically because I'm neurodivergent, and psychology doesn't really work in the framework for a long time for me because it didn't really consider my needs. So I made parapsychology as in topology to broaden the horizons of neural infrastructure. Sensory infrastructure, sensory architecture, and infrastructure. So architecture is how we build, infrastructure is how we use. The same thing. Architecture is architecture is how we build something, how we design something. Design first, and infrastructure is building first. Infrastructure is building on top of the architecture. But architecture is infrastructure. You can make a system, but it's not in all cases. But that's the ground idea. Depending on the kind of knowledge of the system, architecture is infrastructure and infrastructure is architecture. They say isomorphic traits, and you have the actor of the architecture and you have the traits of the infrastructure architecture. So the architecture has to really design, remove all the code into the design philosophy of the system. So it just be a blueprint of like application boundary interfaces, which we're talking about for some reason. But because I love them, yeah. So application boundary. So the application boundary interface of the place can interact with the system without getting ahead of without getting out of human, based on the threshold logic of the social infrastructure. So this is basically a parallel framework again, which I am tripolar. I'm tripolar. It's an Auraseal if alpha, U for umbrella, alpha Romeo, if alpha, F for Sarah, if echo, if alpha, alpha Lima. Auraseal Parapsychology initiative that will make sure that sensory infrastructure is preserved in the frame of reference of me, myself, and I. Because I'm building for myself, it could be a human rights computer that can be discriminate to solve the problem of governance. So you can sue people who don't give you food, water, shelter, based on Muco. So Muco OS is an opposite. You can say Muco, M for Mike, U for umbrella, C for Charlie, O for Oscar, Muco. Now, those are the C's high, you can say Muco, M for umbrella, M for Mike, F for Mike, P for umbrella, K for kilo, O for Oscar, which is a human rights operating system. That can be that works on the protection of human rights and neurodivergence in charity. Thank you for watching this video, guys. If you like, share, subscribe.